Let's do IXL 7th grade W.4. Go to Learning, go down to 7th grade, then over to W.4, which is called Triangle Inequality. Now, before we do this, I want to remind everybody that before you do IXL, you should go over to friedmanmath.weebly.com. And in this section here, I'm going to have, by the time you watch this video, I'm going to have another video called Triangle Inequality right over here in this section. It's going to be right over here. Make sure that you watch that video before doing the IXL. And you should also have a look at the reference pages, which I'm going to do right now. There will be other videos over here, which you should also watch, by the way. So what we need right now is triangles, which is on page 13. So let's go down to page 13. Let's see, where am I? Here we are, page 13. And what do I want on page 13? I want triangles. And under this section called Some Facts About Triangles, we're going to be interested in what's written over here by the number 2. And this is what's called the triangle inequality. And I explain all of this in the video as well. In any triangle, the sum of the lengths of any two sides of the triangle must be greater than the length of the remaining side. And in particular, the two shorter sides, when we add them together, must be greater than the length of the longest side. So, for example, in this triangle, we see here that A plus B is greater than C. We also see that A plus C is greater than B, and B plus C is greater than A. So if we take any two sides and add them together, then the length of those two sides put together will be longer than the remaining side. Okay, and again, in particular, we're going to be interested in adding the two shorter sides to make sure that they are longer than the longest side. And to see why this is, which I go through in the video, consider the figure below. Sides A and B cannot connect because side C is greater than both of them combined. So you see over here in this diagram, A is very short compared to C, and B is also very short, right? In fact, A and B are so short that there's no way, if we try rotating A and B, there's no way that we could connect them to actually form a triangle. So we see here that the length of A plus the length of B is less than C. So not only is A less than C, and not only is B less than C, but even if we put them together, A plus B is still less than C. And when that happens, we will not be able to connect those sides of the those two sides, so we can't make a triangle. Now, what happens when A plus B is exactly equal to C? Then sides A and B would connect exactly on C, and we would get a line, not a triangle. So you see in this case, A is less than C and B is less than C independently, but A plus B is exactly equal to C. But still, we're not able to make a triangle because they connect exactly along C, so we don't get a triangle, we get a straight line. So with that in mind, and again, please watch that video called triangle inequality. It's only a few minutes long, and it explains all of that, I think, a little bit better than I did just now. So going back to this IXL exercise, can the sides of a triangle have lengths 3, 8, and 8? So basically the strategy here is we're going to take the two shorter sides. In this case, two of the sides are the same length. So we'll just say that 3 and 8 are the shorter sides, and we'll say that this other 8 will say that that's the longest side, even though it's the same as the other one. So the strategy is we take the two shorter sides and we add them together. I'm going to use a different color. We take the short sides and we add them together, and we want that to be greater than the longest side. Okay, so the two short sides here are 3 and 8, and we want that to be greater than the other side, which happens to also be 8. So even though it's the same length as this, we'll just call that the longest side. Now, wait a minute here. 3 plus 8 is 11, and 11 is greater than 8. I don't know why I just said wait a minute. No, don't wait a minute. That's fine. So 11 is greater than 8. So we would be able to make a triangle. In fact, that triangle would look something like this. We would have two pretty long sides here, 8 and 8, and then maybe a side of length 3 connecting them. So yeah, we could make a triangle with those 3 side lengths. Okay. Can the sides of a triangle have lengths 1, 1, and 5? So again, we're going to take the two short sides and add them together. And we want that to be greater than the longest side. So the two shorter sides here are 1 and 1. So we'll add those together. And hopefully that is greater than the longest side, which is 5. Okay, but wait a minute. So now I actually do get to say, wait a minute. So 1 plus 1 is 2, and 2 is greater than 5? No, it is not. 2 is less than 5, right? So this inequality does not work the way that we wanted it to. So in fact, we would not be able to make a triangle that has a length of 1 and another length of 1 and a length of 5. If we tried doing that, let's say that this is, let's say, 5 centimeters long, and this is 1 centimeter long here, and this is 1 centimeter long here, we can see that the two short sides are not going to be able to reach each other. No matter how we rotate them, they simply cannot reach each other, and we would not be able to make a triangle. So the answer for this one is going to be no. Remember, when we add the two short sides together, we want that to be longer than the longest side. Okay, so let's try another one. What are the shortest sides here? The shortest sides are 2 and 5. So if we add 2 and 5 together, we want that to be longer than the longest side, which is 9. So 2 plus 5 is 7. Is 7 greater than 9? No, it is not. Right? So we would not be able to make a triangle that has those three side lengths. Again, if we tried to do that, then the side length of 2 and the side length of 5 would not be able to connect over the side length of 9. So the answer there is going to be, again, no. Can the sides of a triangle have lengths 1, 10, and 10? Okay, there we go. So I don't have to keep writing short plus short is greater than long. All right, the short sides are 1 and, yeah, so here I have 2 10s, right? But again, I'm just going to put one of them over here and just put the other one over here. So I want to know, is 1 plus 10 greater than 10? Give me 1 minute here. Okay, I just had to pause for a second because my computer was about to run out of batteries, but I'm back now. And while I was gone, I had time to figure out what 1 plus 10 is. It's 11, which is greater than 10. So that's good. So we would be able to make a triangle with two side lengths that are each 10 inches or centimeters or whatever, and the other side length of 1. All right, I'm going to go, well, okay, so let's do this one. So again, I want to know if the two shorter sides put together are greater than the longest side. So the two shorter sides here are 2 and 3. If we add those together, is that greater than the longest side, which is 5? Now here we get 5 on the left and also 5 on the right. Is 5 greater than 5? Is 5 greater than itself? The answer is no. So that's an example of what we were saying before, where the two sides would connect exactly over the last side, and we would get a straight line, not a triangle. So that's going to be a no. I'm going to go ahead and jump to the next level. Let's see what that looks like. So this is exactly the same as what we said before. The two shorter sides are 3 and 12. So 3 plus 12 is 15, which is greater than 13. So that's going to be a yes there. Okay, so now this is a tiny bit different. Why is this one different? It's not really that different. The strategy is still the same. We're still going to take the two short sides and we want them to be greater than the longest side. This question is just a little bit different because they gave you the longest side in the middle. So I know a lot of you at home, you're going to be doing these IXL exercises, and for the first bunch of problems, the two shorter sides were always these first two, and then the longest side was the last one. So as you're doing these IXL problems, you might get in the habit of just adding these first two and seeing if it's longer than the last one. And if you did that for this one, you would say, well, 6 plus 8 is greater than 2, so maybe you would click yes here. But you have to remember to take the two shorter sides, not just the first two numbers that you see. So the two shorter sides here are 2 and 6. And the longest side is 8. So we get 8 is greater than 8, which is not true. Right? No good. So we would not be able to make a triangle with these three side lengths. Okay, so here we would get the two shorter sides are 2 and 2, so 2 plus 2 is less than 6. It's not greater than 6. So again, that would be a no. We want the two shorter sides to be longer than the longest side. And I'm going to go ahead and skip to the next level here. Let's see what we get. Okay, so again, it's exactly the same thing. It's just decimals, right? So I'll do one with decimals, but the strategy is exactly the same. So the two shorter sides, I'm just going to write S for short and L for long because I'm getting tired of writing short, short, and long a million times. So the two shorter sides are, let's see, 1.6 and 3.3 are each shorter than 6.3. So this is the longest side here. So we're going to write 1.6 plus 3.3 should be, we want it to be longer than 6.3 because we'll get a triangle then. Now, if we add these together, we're going to get 4.9. Is 4.9 greater than 6.3? No, it is not. 4.9 is less than 6.3. So this is no good, right? The two short sides, when we put them together, are not greater than the longest side. So this is going to be another no. Okay. All right. So yeah, all of the problems in this exercise, you just use the same strategy all the time. You want to make sure that the two shorter sides put together are longer than the longest side. Okay. Have a great night.